Okay, now let's look at triangles, trapezoids, and rhombi. And what we're going to do is we're going to take these one at a time and go into them in detail. Triangles you've done for a long time now. You ought to know that the area of a triangle equals 1/2 times the base times the height, or the base times the height divided by 2. Either way you want to look at it there. The base and the height are perpendicular to each other. Very, 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 very important. If you don't get this right, you're not going to get anything right. Now, the other thing that happens is the biggest mistake on calculating the area of triangles is this little baby right here. Forgetting to multiply by 1/2 or forgetting to divide by 2. Guarantee that will catch about 50% of you on your test on areas. You will forget to divide by 2 when you're calculating the area of a triangle. I don't know why. It's just history over the last several years. I've just noticed that. Now, how do we look at the area? And how do we look at this base and height? There's a triangle. It's an obtuse triangle. We're going to use the bottom as the base. Can you use something else as a base? Yes, we'll go into that in just a minute. But we're going to use the bottom as the base. The height is the altitude. Oh wow, where do we come into altitude? Oh, I think back in 5.1, we talked about altitude from the vertex opposite. Height is the altitude from the vertex opposite the base. The vertex opposite the base and perpendicular to the base. That's the definition of altitude. That's what the height is. So the height is the altitude of this side right here. The product of any side and its altitude divided by 2 will give the area of the triangle. So you can use any side as its base, use its altitude, multiply the 2, divide by 2, and get the area. It's a very simple equation. Now, sometimes you may have to use angles in order to get that altitude and to get that height. Trig ratio, so forth and so on, Pythagorean theorem, whatever else. Oh wow, because you're using the altitude, automatically it lends itself to Pythagorean theorem because you're going to divide that sucker into 2, that triangle into 2 right triangles automatically, so you can use that. Now, we're going to look at another little simple visual proof of this thing. We've got a rectangle down here. How do I know it's a rectangle? Well, all of its angles are congruent. Its opposite sides are congruent. I've labeled the bottom as B. I've labeled this side over here as H. The area of the rectangle is equals what? Base times height. Well, I only want the area of this right here, this part down here, this triangle down here. How do I get the area of that triangle? Visually look at it, it's going to be what of it? How much of this is going to be included in that? The area of one of those triangles is base times height. Oh, I'm going to take the area of the whole rectangle, and I only want half of it for that triangle. We're going to divide it by 2. Okay? That's a simple visual proof of that, visualization of that thing right there. We're going to do a couple of really simple examples and then go on to trapezoids. Remember, the base and the height are perpendicular to each other. Also remember that you divide that product by 2 or you multiply it by 1/2. I don't care which, that's the same thing. Most of you, for some reason, will forget to do that and get those problems wrong. Remember that the base and the height are perpendicular to each other. The height has to go through the opposite, has to originate from the opposite vertex. It is the altitude of the base that you use. And then make sure you divide that product by 2. All right, let's look at some samples on triangles. We're going to run through these pretty quickly. Simple calculations. Yes, it looks complex. It's pretty easy. Triangles. Area of a triangle equals 1/2 the base times the height, or base times height divided by 2. The base and height are perpendicular to each other. Here you go. Here's what it looks like. Okay, here's the base, here's the height. And then you're multiplying those 2 and dividing by 2. Let's take example 1. We're given a triangle, we're given its base, we're given its height. What do we have to do? Find the product and divide by 2, and when we do, we find that the area is 336, a very simple, straightforward one. Here is a quadrilateral. Now, I have conveniently divided it into 2 different triangles. You notice I have triangle 1 over here that has a base of 33 and a height of 20. Triangle number 2 over here, divided by this sort of messed up line, has a base of, it doesn't matter which one's the base, does it? Okay, ooh, let's get rid of that. Base of 16 and a height of 21, or a base of 21, a height of 16. Either way, have 2 different triangles. Now, in order to get the figure, the area of the entire figure, what are we going to have to do with those 2 triangles? We're going to have to calculate the area of both triangles and then add them together. So, let's look at the area of the first triangle. Area of triangle number 1 is going to be the base times the height divided by 2. That equals 330. Oh, that was simple. Yeah, well, that would be 10. Yeah, okay, that makes sense. Okay, 330. The second one, 21 times 16 divided by 2 is 168. We add those together, and the area of the composite figure is 498. Fairly simple, fairly straightforward. Here's one that looks simple. Let's see what it is. We have a triangle. Wow, what do we know? Those 2 sides are congruent. This is a right triangle. That's 10. We know those 2 sides are congruent. Therefore, we can call them X. Let one of them represent B, let the other one represent H. Does it matter which one? No. We also know this is a 45, 45, 90. Why? Because it's a right equilateral. No, it's an isosceles right triangle. So it's 45, 45. Therefore, the sides are the hypotenuse divided by the square root of 2. Where did we get that? You're supposed to know it. It's a special right triangle. You're supposed to know those relationships without a formula chart. Next year and the year after and so forth, and in your higher level math classes, you're just supposed to know that. So x equals 10 divided by the square root of 2. Here's our equation. Here we go. Each one of them is represented by 10 divided by the square root of 2. 10 divided by the square root of 2. Well, if we multiply 10 divided by the square root of 2 times itself, top times top, that's 100. Bottom times the bottom. Square root of 2 times square root of 2 is 2. Take the first part, 100 divided by 2 is 50. Divided by 2 is 25. Go over that one in detail. Wow, what other special right triangle are you supposed to know? 30, 60, 90. Get on it. Here's another one, very simple. Okay? We're given a base. We're given one side of a rectangle. We're not given the height, but we're given one of the angles that the diagonal makes with one of the other side. So what are we going to have to use? We're going to have to use trigonometric ratios in order to find that other side. So what do we got? Triangle 1 is what we're finding. We're not finding that one. It's base height divided by 2. What's the base? 24. The tangent of angle 50, that would be opposite divided by adjacent. Tangent of 50 is 24 over h. Solving for h, we get 24 divided by the tangent of 50. h equals 20.14 degree, 20.14. Yeah, let's take that degrees off there. So, the area of triangle 1 is 24 times 20.14 divided by 2. When you do that, you get 241.66. Okay? Nothing new here. You're just supposed to know how to use it. Recognize when you need to use those trigonometric ratios and then use them. Okay? All right. Now let's jump into trapezoids.